7, this is my demo. I'm importing the Yelp dataset here. We're going through the configuration file first. I import the Yelp dataset. I created these two hybrid recommender weights, and here we see that I'm using this new hybrid recommender class I created. And for the evaluator, we're using the NDCG evaluator. I'm using K nearest neighbors, the item recommender, collaborative filtering with 50, in addition to my naive Bayes recommender. So we're going to start with the naive Bayes recommender. In the end, all we're doing is basically this calculation here, but we really want the probability liked it given a feature divided by the probability that disliked it given a feature. These are what we consider our log odds, but it all boils down to this equation. So we need to get the probability of the feature given that they liked it divided by the probability of the feature given that they disliked it, and then we're also going to take into account this user bias here. And we're actually going to do the log of it just to make it a little bit simpler. So the log of this is equal to the log of this. So for all the, again, this code I did actually end up heavily borrowing from Professor Burke's code. I changed a lot, I added a lot of comments, and I changed the variables, and I actually made a few modifications. So please don't give me a 0 for this assignment for plagiarism. So again, we're going through all the users. We have this nice matrix that keeps track of the number of times the user liked a feature or disliked a feature. We also keep track of the number of times the user liked or disliked anything. So for all users, for all items, we loop through those items. If that item's rating is greater than some certain threshold set in the settings file, we increment the total number of times the user liked it or disliked it. We also get the min rating and max rating. That's something I added in here just to make my predict function, my prediction rating, a little more sane. Didn't want to predict something that was greater or less than the maximum or minimum rating that the user gave. So then we go through all the features of each item, and if the user liked that item, then we say the user also liked the feature, and we increment the number of times the user liked that feature. We do the same for dislikes. We then add one to the total user likes and dislikes for that user for Laplacian smoothing, and then we get the bias, that last part of the equation. Now that we have the total user likes and dislikes, so we get the user bias for that user, which is just the log of the total user likes divided by the total user dislikes. It's actually the log of the probabilities, but because the denominator of both of these is actually the same, the total number of items that the user has rated, we don't have to include that. We just use the user total. We also do the same for features, but here we're getting the probability of the feature given that they liked it. That actually also has this probability of the feature. We are really divided by the probability of the feature, but because we're doing that on both of these, it just cancels out and we don't need to include it. So in the end, it's just the probability that they liked a given feature divided by the total number of times that the user liked anything. Same for the probability that they disliked something, and then we get the log odds, which is just the probability that they liked it or divided by the probability that they disliked it given the feature. So then we set the log odds. So wahoo, we have the log odds for all users for all features. So for the predict function, this is also where I changed it before. I think Professor Burke's solution will loop through all features. I think we only want to loop through the features for the given item. So I do that here, and we just sum up the log odds for all features for that item, and then we also add in the user bias. Again, that's really just they're multiplied together, but because they're within a log function, we can just add them. So to get the probability, we just get so we have this log odds thing, and we want to get the logit of it to convert it back into a probability. And so now we have a value between 0 and 1. We multiply it by the range, which is just the difference between the min and max rating by that user. And then we get a prediction, which is just some value between the min rating and max rating that the user gave based on this probability here. So that's our predict function for the naive Bayes recommender. Now our hybrid function, again, we're using item k and nrec, and we're using this naive Bayes recommender. All we have to do is set them both up. We initialize these naive Bayes recommender weights. We have to set the context. I created these public methods because certain things are private and it was complaining. But in the end, we just call setup, train, and predict for both. But on the predict side, we also pull over the weights and multiply the weights by the naive Bayes prediction and the item k and n prediction. So that's my whole thing. Thanks for watching.